Welcome students, welcome to IMST online classes. Now, in the last video we studied about the physical properties of metals and non-metals. Now, after the physical properties we are going to study about the chemical properties. Well, as I've said earlier, chemical properties generally it resembles or it tries to explain the inner properties, okay, the things which you can't see or feel about an object. What does the property of that sense, okay, which you can't see, okay. For example, what it is made up of, how it varies with temperature, how it reacts with other things. So basically we'll study about that. First we'll study about the chemical properties of metals. In the chemical properties of metals we are going to study about the reaction of metals with oxygen, then with water, then with acids, then with bases or alkalis, and at last metal displacement reaction. Now generally all metals react kind of same, okay, same type of reaction. They show same type of reaction, but the rate of reaction varies from metal to metal, okay. So are you ready? Now, so let's study about chemical properties of metals. Now let's study about the chemical properties of metals. That is, firstly about reaction with oxygen. Oxygen is one of the most important substance that is known to us, right? We used to inhale oxygen. So let's see how metals react with oxygen. Generally, all metals react with oxygen to give oxide. Means when a metal reacts with oxygen, it forms metallic oxide. But different metals form oxides under different conditions. Okay, so let's say for example, if you take sodium, sodium is one of the most reactive metals. So sodium does not need anything. Just if you keep the sodium outside openly in air, sodium it directly reacts oxygen present in air. Okay, directly it will react with air and it will form sodium oxide. Sodium, the symbol is Na for sodium, and for oxygen it is written as O2. Sodium oxide, Na2O. Okay. Similarly, if you take magnesium, magnesium is a metal, but it does not, unlike sodium, it does not react directly with oxygen. We need to heat it a little bit. It needs some heat. Okay, but if we burn a magnesium metal, okay, when we burn magnesium metal, it reacts with oxygen present in the air and it converts into magnesium oxide. That is MgO. Okay. Now for zinc, zinc needs even more strong heating than magnesium. If you burn it, zinc generally burns with a blue colored flame. Zinc metal, it generally burns with a blue colored flame and it gives zinc oxide. Iron, it does not burn, okay, means it does not gives flames just unlike any other metal. It directly just converts into ferric oxide. Okay, so this is how metals react with oxygen. Okay, now let's study about reaction with water. Metals react with water. Okay, metals react with water to form metallic hydroxide in most of the cases, and they release hydrogen gas. Now different metals react under different conditions with water. Okay, let's see some example like sodium and potassium. They are the kind of metals that can react even with cold water. They will react with cold water. When sodium or potassium, if they react with cold water, they give sodium hydroxide, or if you take potassium, it will be potassium hydroxide plus hydrogen gas. So that's why sodium and potassium, because since they are reactive with both air and water, they can be stored simply. So that's why they are stored inside kerosene. Okay. Next, magnesium. Magnesium does not react with cold water. Rather, it reacts with hot water or boiling water, and it forms magnesium hydroxide and releases hydrogen gas. Iron, on the other hand, is a type of metal which neither reacts with cold water nor hot water, but it reacts with steam and it gives ferroso-ferric oxide. That is a mixture of ferrous oxide and ferric oxide plus hydrogen gas. Copper is a metal which does not react with water. Okay, neither with cold water nor hot water nor steam, nothing. Copper does not react with water. Okay. Now next, reaction with acids. Reaction with acids. Now metals generally react with dilute acids to give metallic salts, okay, that is corresponding metallic salt and hydrogen gas. If you take hydrochloric acid, the metallic salts will be chloride, metallic chloride, sulfuric acid, metallic sulfate, nitric acid, metallic nitrate, and as for the acid, okay, the metallic salts will be formed. Let's take some example for hydrochloric acid, dilute hydrochloric acid. First, if you take sodium, it reacts with dilute hydrochloric acid to form sodium chloride, NaCl, and hydrogen gas. Similarly, zinc, magnesium, iron, they also react with dilute hydrochloric acid and give corresponding chloride and release hydrogen gas. But copper is a special type of metal because it does not react with dilute hydrochloric acid, neither with sulfuric acid or any kind of acid. Okay, so it gives no reaction. Copper does not react with acid. Okay, so this is how metals react with acid. Next, reaction with bases. Reaction with bases or alkalis. Metals generally they do not react with bases or alkalis, but some metals like zinc, aluminium, they do react with certain bases on certain conditions, under certain conditions, some conditions. Like for example, if you take zinc reacts with sodium hydroxide solution, which is a base, okay, which is an alkali, sodium hydroxide solution, to form a salt, that is sodium zincate, and evolves hydrogen gas. Similarly, aluminium, it also reacts with sodium hydroxide solution, okay, but generally we have to heat it. This reaction needs some heat, okay. Then it forms sodium aluminate, and it also evolves hydrogen gas. So this is how metals react with base. Okay. Now, if you want, you can pause the video and note it down. Okay, and do note everything: reaction with oxygen, with water, with acid, and also with base. Metal displacement reaction. Now, imagine you're in the classroom, okay, and you want to sit in a place. You have to sit at a different position than yours. But when you go there, you find that someone else is sitting there. So what would you do? Okay, you want to sit there, but someone else is sitting. So what will you do? There are two possible cases. First, either you will remove, if you are quite strong, you will remove that person and you will sit there, right? Or if you may ask your teacher that he or she will help to you while sitting there, or else you will sit in some other place. You won't sit there because someone else is already sitting, right? The same case is for metals in this reaction. Generally, in case of metals, there are some metals which are highly reactive and there are some metals which are very low reactive. So what happens? A high reactive metal has the ability to remove a low reactive or a less reactive metal from its salt solution. This type of reaction is called as displacement reaction. Okay, a reaction in which a more reactive metal displaces a less reactive metal from its salt solution is called as displacement reaction. Okay. Now, for example, magnesium is quite more reactive than copper. So, if you react magnesium with copper sulfate solution, which is blue in color, after some time, the color of the solution becomes colorless or fades. Okay. The color fades. That means the solution has converted into magnesium sulfate and copper has been displaced. Okay. Now the question is how to know that which metal is highly reactive and which metal is low. Okay. To know that, this list was made. Okay, and the series. So they obtained a series, and that was given the name reactivity series. So reactivity series is the arrangement of metals in the decreasing order of the reactivity. Okay. So in the reactivity series, the metal at the top is the most reactive metal, and the metal at the bottom is the least reactive metal. Okay. So the more reactive metal can replace the least reactive metal, but the reverse can be done.